Welcome to the 38th session of LMS program for BSc subject mathematics and semester 5th semester. The title of the paper is Numerical Analysis. So the third unit is finite difference, in which in this session we will understand the concept of the nth difference of a polynomial. We have a recap first. In the last session, we have understood some of the properties of the forward and shift operators. So at the end of this session, we can able to understand the concept of nth difference of a polynomial of nth degree is a constant, and the nth plus 1 and higher differences of nth degree polynomial are 0. So what does it says? The nth difference of a polynomial of nth degree is constant when the values of an independent variable are at equal intervals and the nth plus 1th and higher differences are 0. So for that is, we can say that if we take a polynomial of nth degree and we will make the nth difference, it is constant, and then n plus 1th difference will become a 0. Difference will become 0, right? So we will consider here a polynomial. So it is a polynomial. F of x is a polynomial of degree nth degree in x, right? Here we can see. Now we will apply for this forward difference. Now here we can see that we have applied here forward difference for this. This is delta of f of x. So forward difference here, where n here is a positive integer, and here all a0, a1, a2, a3 are all constants here. Okay, right? So if you apply here, how we can apply? Delta of a0, a is a constant, as I have told. A0, a1, a up to an are constant. We cannot apply the forward difference to the constant values, so I kept outside. Delta of x, delta into x square, delta up to delta to the power of n. Now if you apply the formula, this will become 0. For a constant, forward difference will be 0. We have wrote it here. A1 as it is. What is this delta of x? Delta of x is x plus h minus x. That is, delta of f of x is equals to f of x plus h minus f of x. That formula we have applied here, right? Similarly here also we have applied it. Similarly for delta cube also, delta into x cube also we can apply. So up to nth we have applied here. Okay. Now this what we have is expanded the terms here up to here. Here we have applied a binomial theorem expansion. So here we have applied, if you plus x plus 1, x plus h minus x, xx get cancels. Sorry, xx get cancels and h will be left. A1 plus h, here it is. Similarly, you can simplify here, a plus b whole square minus x square. This one also a plus b whole. Like this we can expand all the terms. This term is expanded by binomial theorem. Here it is, nc1 x to the power of n minus 1 h plus nc2, like this, right? Here we are wrote, expand the last term x plus h to the power of n by binomial theorem, and here we will rearrange all the terms. How we are going to rearrange? In the increasing powers of x. That is, highest power will be here, and as it goes on, lower powers will be here. Okay, and at the same time we will denote the coefficients of x by b0, b1, b2, b3. Okay, then what we are going to get? This is the equation we are going to get. Okay, this is called first forward difference of the given polynomial. Okay, now it will look like a polynomial, same polynomial, but its degree is less comparative to the first equation, as it is f of x. If you compare this equation here, b0, b1, you can see here degree is x to the power of n minus 1, whereas you can see it here, it is the same polynomial with the degree is x to the power of n, right? F of x and delta of f, what is there? The difference is powers. We are comparing the powers. It is x to the power of n, here x to the power of n minus 1. Thus, the first difference of f of x is another polynomial whose degree is n minus 1. Right? So, the degree of the polynomial is reduced by 1, we can say, as we compare it to f of x and delta of x. Now, I will apply same method to get delta square of f of x. That is second forward difference. If you apply for this one, what happens? You can see it here. Right? We have to apply delta square of f of x, this for this one. So, delta of b naught, b1 as it is, delta of x square, b naught, b2 as it is, n is constant, delta x to the power of n minus 1. Now what happens? This will become 0, right? This term will become 0, right? So this b1 as it is we have kept, b1 we have kept as it is, right? b1 we have kept as it is. So delta, this formula we are writing, what is this? Delta of x is nothing but an x plus h minus x, right? So b2 we have kept as it is, delta square x plus h whole square minus x square, wherever x is there, that is replaced by x plus h. Okay, remember this. Okay, for this one also we have applied it, right? Now, after applying this, how it will convert? Same procedure we are applying as first we have applied it. So it will changes like this. We have to apply again here binomial theorem for the last terms, that is for this one, for this x plus h to the power of n minus 1. So we can get, and we will denote here the coefficients of x by c1, c2, c3 and highest power to lowest power we will arrange it. So you can see this is a polynomial with the degree n minus 2, right? So if we proceed, again if we apply delta, that is forward difference for this one, that is delta to the power of 3 times of f, that is the third forward difference. What happens? We will get a polynomial which is of degree n minus 3. But as we proceed, so nth difference, delta to the power of n of f of x will be an into n into, here you can see, here it is, first term an is there, n minus 1, n minus 2, n minus 3, n minus 4, dot, it will goes on, and h square, h cube, it will be h to the power of n. Right, we can see n minus 1, n minus 2, dot, up to 3 to 1, and it is h will be h to the power of n. In simple way, if we write, it is nothing but an an into n factorial times of h to the power of n. Thus, the nth difference of a polynomial of nth degree is a constant, we can see. There is no x term in this, you can see it here, right? Here. So it is a constant. So constant, if you make again difference, n plus 1 to the difference, it will become 0, we know that, right? Therefore, the nth difference of a polynomial is constant and n plus 1th difference is 0. Thus, the higher difference of the nth degree polynomial are 0, right friends? So here some of the books for references, right? So thank you friends.